I just want to let you guys know I've been sick recently, so my nose is going to sound a little stuffy. So just, ignore it as best you can, and let's get into the video. Yo, okay, what's up guys? So today we'll be talking about how to do operations with complex numbers. So let's start with just adding and subtracting, okay? So adding and subtracting complex numbers is basically identical to adding and subtracting polynomials, okay? So let's just start, let's start with this problem over here. So try, pause the video, try to work this on your own. So let's start with this one. So like we learned with polynomials, you can, the commutative property, you can basically just take off parentheses. So we can turn this into 4 plus 6i plus 2 plus 9i, and then you just combine the like terms. So we have let's do 4 plus 2 is 6, and we have 6i plus 9i is 15i. Yeah, so 4 plus 6i plus 2 plus 9i is 6 plus 15i, okay? Easy, right? So let's move on over here, okay? So 5 plus 3i minus 4 plus I. So remember what we learned, we're going to have to distribute the negative sign and then take off the parentheses. So we're left with 5 plus 3i, and then I just like to do plus negative. So plus negative 4 plus negative I, because remember we're distributing that negative sign. So now let's just combine like terms. So 5 and negative 4, excuse me. So 5 plus negative 4 is 1, and then 3i plus negative I is 2i. So 5 plus 3i minus 4 plus I is 1 plus 2i. And if any of this is new to you, make sure to check out my video for chapter 1 part 1, where I teach kind of how all this works. So now multiplication. So multiplying complex numbers is very similar to multiplication of polynomials, but there is one big difference, which I'll get to in a minute. So you can try these on your own. Just pause the video if you want. But let's start working these out. So I'll start with this one over here. So 4 times 3 plus 6i. So 4 times 3 is going to be 12, and 4 times 6i is going to be 24i. So yeah, pretty easy, pretty straightforward, right? Now let's work on this. Look at this one, okay? So 5i times 2 plus 3i, okay? Or 5i times 2 plus 3i, okay? 5i times 2 is going to be 10i, okay? Plus 5i times 3i is going to be 15i squared, okay? And what do we know about I squared? Well, we know that I squared is equal to negative 1. So instead of writing 15 times I squared, we can write that as 15 times negative 1. So let's rewrite this. So 5i times 2 plus 3i is equal to negative 15 plus 10i. Okay, look at that. So now let's get a little more complex. Okay, now into multiplication with complex numbers. Never mind. So now let's work on some more complex number multiplication. So let's do 3 plus 5i times 6 plus 7i. Like I've said before, I personally like FOIL. You can use what other method you want. So let's start multiplying. So 3 times 6 is 18. Oh, that was a bad 8. Here, let me do that again. Is 18 plus 3 times 7i, which is 21i. Okay. Now we have 5i times 6, which is going to be 30i. And then we're going to have 5i times 7i, which is going to be 35i squared, and which I've mentioned before, I squared is negative 1, so we can say negative 35, okay? So now it's combined like terms. So we have, I like doing that, 18 plus negative 35 is negative 17 plus 21i plus 30i, which is 51i. So, okay, now look at that. So 3 plus 5i times 6 plus 7i is negative 17 plus 51i. Multiplication with complex numbers is very similar to multiplication with polynomials. You just have to be careful when I is two different powers. Quadratic functions. You may be wondering, how is this related to complex numbers? But they play a very important role. So, if you didn't know, finding the root, or 0, of a quadratic function is to find where y is equal to 0. Or, in other words, the x-intercept. So, let me just make a little graph right here. So, if we would have a graph right here, it's the root, or 0, is wherever it intersects, wherever this parabola intersects with this x-axis. So, let me give you one example. Maybe we could have y is equal to x squared, and in this case, the root is going to be at 0, 0, okay, or at 0. So, how do you find the root? Well, you find the root by setting y to 0. So, if y is equal to 0, then I get x squared, and I just solve for x. So, square root, and we get 0 is equal to x. So, something important to know about parabolas is that not every parabola has an x-intercept. So let me give you an example. Let's do y is equal to x squared plus 2x plus 10. And if you plug that into, a Desmos calculator, it's going to look something like that, okay? Say around that, okay, kind of bad drawing, but there we go, okay, something like that. And notice it doesn't intersect with the x-axis, okay? Doesn't touch it, okay? So, let's find the root, or 0, of this quadratic function, okay? So, what you could do is you could set y to 0, but, when you get to something more complicated, then, or that doesn't factor evenly, you can go to the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac, that's c, okay, all over 2a, okay? So let's solve this, okay? Let's start plugging in stuff, okay? So what is b equal to? B is equal to 2, okay? So we have negative 2 plus or minus 2 squared, which is 4, minus 4 times a, and what is a? A is 1, because it's 1x squared, okay? And times c, okay? So what is c? Well, c is 10, okay? Times 10. All over 2 times a, which is just 2, okay? A is 1, so just 2, okay? So let's start simplifying. So we have negative 2 plus or minus the square root of 4 minus, well, what's 4 times 1 times 10? That's 40, okay? Divided by 2, okay? And we can keep simplifying this. So we have negative 2 plus or minus the square root of negative 36 divided by 2, okay? So now, okay, well, we're stuck, okay, because we can't simplify it anymore, because notice it's negative 36, okay? Well, having learned about imaginary numbers, there is a way to avoid this, right? Because how we can write it, negative 2 plus or minus the square root of 36 times the square root of negative 1, right? Divided by 2, okay? So, it's going to be simplified to negative 2 plus or minus negative 2 plus or minus 6i divided by 2. So, I mean, if you want to simplify that more, we can kind of cross out the 2, so we get 1 and 3. So our root is going to be -1 plus or minus 3i divided by 1, or let's just divide by 1, we don't need. So this is our answer right here. So notice we're using imaginary numbers because the root technically does not exist. The only way it can exist is if we're using these imaginary numbers, the square root of -1. So that's how we can apply complex numbers to quadratic functions. Okay, thank you guys for watching. So we finally learned how to do operations with complex numbers and how to apply them to quadratic functions. So in next video we'll be talking about polynomial factorization. So that'll be coming out soon. Thanks for watching. Peace.